Hello friends, today I will discuss about theory of equation. Polynomial equation. An equation of the form a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus plus an minus 1 x plus an equal to 0, where a0, a1, a2, an minus 1, an are constants. The exponent of the highest power of x in a polynomial is known as the degree of the polynomial. Provided the coefficient of the highest degree term is non-zero. The above polynomial equation is of degree n if a0 is not equal to 0. Examples of polynomial: 2x square plus 3x plus 4 equal to 0 is a quadratic equation. Five x cube plus 7x square plus 2x plus 5 equal to 0 is a cubic equation, that is equation of degree 3. Similarly, x to the power 4 minus thrice x square plus 5 equal to 0 is an equation of degree 4. Equation of degree 4 is known as biquadratic equation. Similarly, equations of fifth degree is known as quintic equation, and equation of sixth degree is known as sextic equation. Now, complete equation. An equation is said to be complete when it contains terms of all powers of x. Otherwise, it is an incomplete equation. Example of complete and incomplete equations: x to the power 4 minus 5x cube plus 4x square minus 3x plus 2 equal to 0 is complete equation because each power of x up to 4 is present in the equation. There is 4, 3, 2, 1 and this is 0. Now 5x to the power 4 minus 3x square plus 12x minus 5 equal to 0 is incomplete because here term containing x cube is not present. This is 4, 2, 1 and 0. X cube is not present, so this equation is incomplete. Solution of an equation. Solution of equation. The solution of an equation is meant the determination of all the roots which satisfy the given equation. An equation is said to be numerical or algebraical according to its coefficients are numbers or algebraic quantities. Examples: x cube minus 5x square plus 6x minus 7 equal to 0 is a numerical equation, whereas a0x cube plus 2a1x square plus thrice a2x plus a3 equal to 0 an algebraic equation. Division algorithm for polynomials. Let fx not equal to 0 and gx not equal to 0 be two non-zero polynomials. Then there exists uniquely two polynomials qx and rx such that fx equal to qx into gx plus rx, where either rx equal to 0 or degree of rx is less than degree of gx. Remainder theorem. Let gx is equal to x minus a polynomial of degree 1. Then from division algorithm we have fx equal to x minus a into qx plus rx, where degree of rx is less than degree of gx, which is equal to 1. Therefore fx is equal to x minus a into qx plus r, where r is a constant. If we put x is equal to a in above equation, we have f is equal to a minus a into qa plus r, which is equal to r. Therefore, r is equal to f of a. So we can see that if the polynomial fx is divided by x minus a, then its remainder must be equal to f of a. Factor theorem. If f is equal to 0, then the remainder is 0. That is, the polynomial fx is completely divisible by x minus a. Since we know that fx is equal to x minus a into qx plus r, since we know that fx is equal to x minus a into qx plus r, and r is equal to f of a. If f is equal to r equal to 0, then we have fx is equal to x minus a into qx plus 0 equal to x minus a into qx, implies that fx is a multiple of x minus a, implies x minus a divides fx completely.